So on section 2.9, part of the thing that people struggle with is writing those inequalities. You're going to have to do this on your own over the next couple problems, so you want to make sure you know how this all comes together. So if you think about the things that are being made, so hats and shirts, we have 1,000 square yards of fabric. So if it's 2 yards of fabric per hat and 4 yards of fabric per shirt, that has to stay less than or equal to 1,000. So that's our first inequality. 2x plus 4y is less than or equal to 1,000. So x is the number of shirts we make, and x is the number of hats we make, and y is the number of shirts. So my second inequality is going to be the buttons, and that's going to be 5 times the number of hats plus 5 times the number of shirts, and we only have 1,500 to work with, so that has to stay less than or equal to 1,500. Same thing with the thread. So 100 times the number of hats plus 40 times the number of shirts is less than or equal to 24,000. So when we're going to graph these to find out what our intersection area is, so we need to solve each of them for y. Keep in mind what your like terms are. So we're going to subtract 2x from both sides, and I put this outside of the 1,000 because I can't combine those two, so I'm just going to rewrite them. So I have 4y is less than or equal to 1,000 minus 2x. Divide everything by 4. Y is less than or equal to 250 minus, and I'm going to leave this as a fraction because I find it easier to graph when your slope is a fraction rather than a decimal, so 1 over 2x. So when I graph that one, so I'll do this just a little bit at a time, when I do that one, I start at 250, my y-intercept, and my slope is -1/2, so I'm going to go down 1 over 2, and I can do that with the teeny tiny boxes, or you might notice that you have boxes, these 5 by 5 boxes, and your scale is the same on both your x and your y-intercept. So if your scale is the same, you can actually go down one of those big blocks and over 2, and that will give you a little bit better of an idea for what's going on overall. So I'm going to try to draw that line just using my sheet of paper. And then am I shading above that or below that? Below, because y is less than or equal to. And this should be crossing here, not here. It's a little bit off there. So then the second one, 5x plus 5y is less than or equal to 1,500. Same process, subtract 5x from both sides. So 5y is less than or equal to 1,500 minus 5x. Divide everything by 5. 5y is less than or equal to 300 minus x, or minus 1x, which means I am starting at 300 and going down 1 and over 1. And again, I am shading below that. And the final one, 100x plus 40y less than or equal to 24,000. Subtract 100x. And I'm going to run out of room. So I got 40y less than or equal to 24,000 minus 100x. Divide both sides by 40. Not 4D. So if I have y is less than or equal to, is that 600? Yeah. So 600. And then the 100 over 40, if you leave that, if you actually do that division, you get 2.5, so you get 2.5. But it's easier, again, if you leave that as a fraction. So 100 over 40, those zeros can divide out. So and then I have 10 over 4. Both 10 and 4 are divisible by 2. So then I can write that as negative 5 over 2x. And that's easier to graph that way than trying to go down 2.5 and over 1. So you go up to 600, where you can't see it, up to 600. Go down, and this is where it's especially easier to use the blocks of 5 by 5 instead of just going down 5 and over 2. So you can go down 1, 2, 3, 4, 5 and over 2, and then down 1, 2, 3, 4, 5 and over 2. And the reason you kind of want to do that and show more than a couple of points on there is because you need to be able to see the intersection points, and I'll talk about that in just a minute. And once again, we're shading everything below it. So this intersection area that's hard to see once you've done all your shading, we have points of intersection here, 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 and here. So this part makes up our triple shaded area. So everything in here, in this highlighted area, represents a possible solution, a possible combination to our, to this situation. So possible combinations, I could have 100 hats and 100 shirts, but where I'm going to find the maximum, so I'm not going to fill out this part with you, I fill that, you guys can figure that out. The impossibles are going to be outside of that triple shaded region. But where I'm going to maximize my profits are going to be at my intersection points here, here, so it's basically my corners, here, here, and here. I think I go further than that, actually. Okay, so not, oh, that's what I did wrong. Okay, so this part right here, that is not part of our solution. I highlighted too much. So this part, I need another color. So my maximum points are going to be found here in the purple. And that's where careful graphing and careful shading is important. So to check those profits, to see which is going to be the most advantageous, the company makes $1 profit per hat, and then hat was our X, and $3 per shirt, that was our Y. That's going to give us our profit. So I test each of these points. So I have 0 and 200. So if I have 0 hats and, sorry, 250, I should say, 250 shirts. So 0 times 1 gives me 0, 3 times 250 gives me 750. So this particular one's going to give me a profit of 750. My next one is at 100, 200. So I'm going to do 100 hats plus $3 times the 200 shirts. That's going to give me 100 plus 600, so that's $700 for that one. My next one, because I'm only checking the corners, is going to be 200 and 100. So 1 times the 200 hats plus 3 times the 100 shirts. 200 plus 300 is going to give me 500. And then my final option is the 250 hats and no shirts, which, as you could probably guess, is not going to be our best option. That's going to be 3 times 0. So that's only going to be 250. So our best option, the way that we're going to maximize our profit, is going to be by making 0 hats and 250 shirts. So that's our combination that we're looking for that one. 0 hats, 250 shirts. So that's that front page. That's kind of the general idea. One other piece of information that I want to talk about. If I have something as simple as X is less than or equal to 15, how could I graph that? How would I graph that? Well, how about this one? What if I have y is less than or equal to 12? How do I graph that? Yeah, it's just going to be a horizontal line. So a horizontal line at 12. 1, 2, 3, 4, 12. So I make my horizontal line, and then where do I shade? If y is less than or equal to that, where am I going to shade? Below. So if I have x is less than or equal to 15, how is that going to be different than the y is less than or equal to? Right, it's going to be a vertical line. So I'm going to have a vertical line at x, and am I going to shade to the left or to the right? To the left. So we hadn't really talked much. We've done the y's a lot. The y is less than a number or y equals a number. We've graphed those plenty. We haven't really done the vertical line for x, so I wanted to make sure I was clear about that before you guys moved on to number 2. So does anybody have any questions on that first page? All right. You guys have the rest of the period to work on the rest of this. If you need any help, please let me know. And have a good day.